Let's run through complete solutions to the first free response question from the 2025 AP Calculus AB exam. Now, this is a calculator active problem, so make sure you have your calculator beside you so you can follow along with me. Let's dive in. Now, this is a word problem, and throughout this question, an invasive plant species is attacking a fruit grove, and we need to figure out what's going on. So, we're given a model for the number of areas affected by this invasive species. We're calling that C of t. And it's this arctangent function. And we're also given for free, that's nice of them, an expression for the derivative c prime. And in this first question, they simply want us to know what is the average number of affected acres. So really, they're asking us here for the average value of a function. We know a formula for that. Let's pull it out. And it's important that we include that formula because we're asked to show our work. So in order to get credit, we need to include that formula. So the average value of a function involves an integral. So it is the integral over the period of time that I'm interested in. So t is 0 up to 4. It is this c of t expression. I could write it down, but I can also just write c of t. They've given me that notation. And now what I need to remember is I divide the answer there by the length of the interval. It's length 4 in this case. I'm really applying the formula here and writing it as 1 over 4 minus 0. So they want us to actually calculate this. So let's pull up our calculator. Okay, so I'm going to take a quarter. Whoops. I'm going to take a quarter of this integral. So I'm going to hit the math menu, entry 9, and then it is the integral of 0 up to 4 of this expression. So the rule for c of t is 7.6 times arctangent tan inverse of 0.2 times my variable. I'm using x on my calculator, and now I can hit enter. But before I hit enter, we should make sure that we are working in radians on our calculator. I know you always think your calculator is set in radians. I know I always think that my calculator is set in radians. But your arch nemesis in class might have been messing with your calculator and changed it to degrees. So it's always worth checking before you start doing some problems, sitting an exam, that your calculator is in radians mode. When I hit enter here, I get my answer as 2.778 to 3 decimal places. So this is 2.778. That is what we are looking for. So that's the average number of acres affected over this 4-week period. Now, how are the points divvied up here? Well, I certainly get 1 point for my final answer, but we were also told show our work. So we're going to get 1 point for something like this average value formula. That's our other point that we need to have there to justify our work. Good job. On to part B. Here they're asking us to find a specific time where the instantaneous rate of change is equal to the average rate of change over those first 4 weeks. That sounds like solving an equation. So let's set up the equation because they're asking us to show our work, and then we'll use our calculator to solve the equation. Simple. So the instantaneous rate of change of c, that is a fancy long-winded way of saying c prime of t. That's going to be one side of my equation because you'll notice I've got this really nice equals here. The other side of my equation is going to be the average rate of change of c over that period of time. So I need to have my nice equals sign, and I need to write down the formula for the average rate of change. Contrast this with part A, where we were looking for an average value. Here we're looking for an average rate. We need to keep these formulas right in our heads. So the average rate of change formula for C, I'm going to take C of 4 minus C of 0 and divide that by 4 minus 0. That is what we end up with as our average rate of change formula. This is the equation. Let's type it into our calculator. Okay, so I can go to y equals and enter these two expressions. So the left-hand side is c prime of t. That is 38 divided by 25 plus my variable squared. That is the left-hand side. The right-hand side is going to be c of 4. So that is 7.6 arctan tan inverse of 0.2 times 4. That is my variable value. I'm then supposed to subtract c of 0, but notice c of 0 is just 0, because what I end up with is an arctangent of 0. That is 0. Everything will become 0. So I could subtract 0 there, but I will do that just for completeness. So subtract 0, all divided by 4 minus 0, that is just 4. I'm going to graph these two sides of the equation, their expressions, and then find where they're equal. So let's do that. So I'll hit graph. Aha, okay. So I have a value here. I've got two intersection points. One of them is occurring in the negative region. I'm not interested in negative time. That doesn't really make sense in the context of this problem. So in order to find this time, I'm going to use my intersection calculation. So I'm going to hit second trace because that pulls up my calculate window. I'll hit option number 5, that's intersect. Now on your calculator, you just pick a first curve, a second curve, and hit enter for your guess. Here I'm doing a left bound and a right bound. This app's a little bit different. And then a guess. And so what I end up with is 2.154 as the solution here. As the time where these two expressions are equal. Great. So how are the points divvied up here? Well, I get 1 point for this correct expression for my average rate of change. And then I get 1 point for this final answer, as long as I've included the equation. Okay, if I just write down t equals 2.154 and nothing else here, I actually won't get any points at all, because I'm not going to get that average rate formula point, and I'm not going to get the justification showing the equation part of that second point. So let's make sure we include all the relevant details, get full credit. Now, part C is asking us to write a limit to describe some long-term end behavior of what's going on here, and then evaluate that limit. Okay, well, we could use our calculator for this, or we could try to use our calculator, but we actually don't need to, and our calculator won't help us that much. It could maybe help us guess the answer, but if we've got enough background knowledge in our heads, this is super quick. We don't need to type anything into our calculator. So what is this limit that's going to describe the end behavior? Well, end behavior is what happens as your variable gets really, really large. Either positively really, really large or negatively really, really large. In this context, it only makes sense to be looking at positive time. So I'm going to be looking at the limit as t goes to infinity. And what is it that I'm looking at the limit of? Well, it's asking about the end behavior of the rate of change of the number of acres affected. Well, the rate of change is c prime. So this is just going to be the limit as t goes to infinity of c prime of t. If I wanted to be fancy, I could write out the formula for c prime, 38 over 25 plus t squared. But that is the limit they are looking for. And they want us to know what happens when this expression here, when the t gets very, very large. Well, when t gets large, t squared gets even larger. So I've got this constant on top, 38, getting pummeled into the ground, divided by something that is just getting massive, 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 massive. So that tells me that this limit is going to collapse down to 0, because I have that constant 38 being divided by something that is getting really, really large. When you divide a constant by a large number, you get something pretty small, close to 0. We don't need to do anything with our calculator here, but if you weren't sure, if you wanted to verify or sanity check your answer, you could always graph c prime of t and see what happens to the value as you let the variable on the horizontal axis get really large. You will see it collapse down to 0. So here, how the points divvied up, I get 1 point for my limit expression, and I get another point for knowing that it equals 0. Nice. Okay, the final part of this free response question, part D. This is probably where you're going to do most of the work, but let's read what is going on here. So after the first 4 weeks, somebody starts panicking and says, we need to do something about this invasive species, so measures are taken. They don't specify what, but we have this new expression, A of t, that's giving us the number of acres affected when t is larger than 4. So you can see we have the original C, that was what was happening in the first 4 weeks, and then we're subtracting off some piece. So the hope is that we're actually making a smaller number of acres be impacted as time passes. Okay, well, they want us to know, where does this new quantity, A of t, reach its maximum value? So at what time is the number of impacted acres largest? And again, we need to justify our answer. Well, there's a couple of flags going up here that make me think this is a pretty standard type of problem, because I see they're asking about a maximum value of this function that I have a rule for, and it's happening over a closed interval. So that makes me think I can use the closed interval method, maybe you call it the candidates test, to figure out what the largest value of A is and where it occurs. So the best way to justify in this sort of situation, I think, is to use a table of values. So I'm going to have t and over here A of t. For the candidates test, the closed interval method, I always need to check the endpoints. So when t is 4 and t is 36, one of those might be giving the maximum value of A. But I also need to find potentially some other t values to check. And those are coming from the critical points of A. So to find those missing t values that might be giving me a maximum of A, I need to solve A prime of t equal to 0. That will give me the other possible candidates that I need to check. This is standard, this type of problem. Using the candidates test, this is the very next thing that we need to do. So I have this expression right up here for A of t. So let's differentiate it to figure out an expression for A prime. So I have these two terms. So A prime is going to equal C prime of t, and then I'm going to subtract off that next term, which is an integral. Well, this type of integral should always be making me think fundamental theorem of calculus, because I'm differentiating an integral. The variable I like, t, is appearing as that upper limit. So the fundamental theorem of calculus tells me this is just the integrand given back to me when I take the derivative of this integral. Remember, fundamental theorem of calculus says integrating, differentiating, undo each other. So I will get 0.1 ln of t as the derivative of that second term. I'm subtracting it off, and I want all of this to be equal to 0. Well, c prime of t, I know an expression for that, right? C prime of t was just this. So it was 38 over 25 plus t squared. So I want to know where this quantity is 0. Well, let's pull up our calculator and graph that left-hand side. So I will clear some of the stuff that we've been working with. I'll clear that second one. Now, this first rule, I went, oh, that's helpful because it's the first C prime still, so I can use that. So it's 38 over 25 plus the variable squared. I'm then going to subtract 0.1 natural log. Whoops, that's not natural log. Natural log of x. So I could just hit graph here, but I'm going to go into my window and clear out these x variables. So I restrict my attention to x being between 4 and 36, because I know that's what I am interested in from the problem. So when I do that, okay, my calculator's already found that 0 for me, but I need to find where that graph crosses the x-axis. I want to know where that quantity is equal to 0. So I'm going to hit second trace to pull up my calculate menu, hit option 2, find a 0. I'll give it a left bound, I'll give it a right bound, and then I'll make my guess. So this occurs when t is 11.442. Okay. So that's the only other t value I need to consider for the table in question. So let's replace that question mark with 11.442 as my final t value. And now I'm going to use my calculator to figure out what a is doing at each of these t values. Okay, so let me clear out of this for a second. Now what I'm going to do is, I don't want to have to type in all the numbers if I don't have to. So this x value that we're currently at, that x-intercept, I'm going to store that as a different variable. So x, I'm going to hit stow. I'm going to store that under the variable a, just so whenever I want to use that, I can evaluate nicely at x equals 11.442. Okay, so we had our 3 t values in our table that we need to check the value of a of t for. So let's use our calculator to do that too. So I'm going to take the rule for a of t, which remember was c of t minus that integral. So let me type this in as my y2 variable. So the rule for c of t is 7.6 arctan of 0.2 times my variable. Subtract this integral, so I'm going to hit math, entry 9. I'm integrating from 4 up to my variable of 0.1 natural log of x. That is my expression for the rule a of t. I can now quit out of this and just use the calculator to figure out these values, rather than type in that rule over and over again. Let me show you what I mean. So if I hit alpha trace, I can see I can pull up y2, and I can use function notation to describe that as the input t equals 4. So when t is 4, I'm getting 5.128. Okay, let's do the same thing, alpha trace. Alpha trace y2, and I'm going to evaluate now at 36. When I do that, I get 1.743 to 3 decimal places. Now if I quit out of, or call alpha trace one last time, y2, this is when I'm going to call up that stored variable a. That was when t was 11.442, and this gives me 7.317 as my value there. Okay, done with calculator. Let's close that over. And now I just notice of those 3 values I figured out, 7.317 was the largest. So let's just write down our answer. The max value of a of t is at t equals 11.442 weeks from the table. How were my points divvied up here? Well, I get 1 point for justifying. So for me in this kind of problem, I'm always going to justify using the candidates test, using this table of values. That's straightforward. You can use something like the first derivative test, maybe the second derivative test, but generally I find those are more work. You're more likely to make a mistake and spend more time justifying using those. So always go for the table of values when you can. When it's a closed interval and you want a max or a min value, you can't beat it. Okay, we also got 1 point for knowing that we had to use a prime of t being 0 to find the non-endpoints, the non-endpoint parts of that table, that 11.442. We found that by solving a prime of t equals 0. Our last point was just for, with all that justification done, getting our final answer, 11.442. Not too bad altogether, maybe? I don't know. You decide. Okay, and there you have it. We are off to the races. That is the first free response question from the 2025 exam on the books under our belt. How did you get on? Let me know in the comments. If you're a bit rusty on your calculator skills, I'll put a link right here and in the description to my calculator skills video. In it, I go through the 4 calculator skills that you need to know to do well on the AB Calculus exam. They come up every single year. If you can master those, you'll be in really good shape for the calculator sections, both the free response and the multiple choice. I'll also put a link to the full playlist of the free response questions from the 2025 exam, so check the rest of those out if you're working them in order. Apart from that, I look forward to seeing you in my next video. Bye.